Tired of confusing tech jargon? Welcome to the Why Explained. We cut through the noise to decode the systems and explain the foundational principle.
You know, we do it probably 100 times a day, right? You type in a website, you hit enter, and poof, it just appears. But behind that one simple click, there's this incredible journey that crisscrosses the entire globe in like a fraction of a second. So today, we're going to trace that journey from the very beginning to the very end.
I mean, really, stop and think about it for a second. You search for a website, and it just shows up. How on earth does your computer, the one sitting right there on your desk, know exactly where to find the data for Google out of literally billions of possibilities, and then get it back to you immediately? It's honestly kind of magic, right?
Well, it all boils down to a simple translation problem. See, we think in names, like Google.com, but computers, they speak a totally different language, the language of numbers. To find any website, your computer has to have its unique numeric address. So the whole journey, the very first step, has to be translating the name you typed into the correct number.
And it absolutely has to be the correct address. Just imagine a website is stored on one specific server somewhere in the world. With billions of servers online, your computer can't just go door to door asking, "Hey, is Google here?" No, that would take forever. It needs a precise location. And that precise location is called an IP address. You can think of it as the internet's version of a street address for a house. It's this unique string of numbers that tells your computer exactly which server, out of all those billions, is holding the data you're looking for.
So, how do we get from the name we all know and love to the number the computer needs? Well, that's where the first hero of our story comes in. Let's talk about the system that makes this whole translation possible, the domain name system, or, as you'll hear it called, the DNS.
To put it simply, the DNS is basically the internet's giant global phone book. It's this massive database that stores the name of pretty much every website and matches it to its corresponding IP address. It's the essential bridge between our human language and the computer's number language.
But here's the really clever part. The DNS isn't one single giant database sitting in some building somewhere. That would be way too slow and would crash all the time. Instead, it's more like a global library system. The information is spread out. It's distributed across thousands of smaller, specialized servers all over the world. And that is what makes the whole system so incredibly fast and resilient.
So because of this super smart distributed system, whenever your computer needs an address it hasn't seen in a while, it kicks off this lightning-fast, three-stop treasure hunt to find the right IP number.
So here's how that little treasure hunt works. First, your request hits what's called a root server. Think of it as the main global directory. It sees you're looking for a .com website and points you to a specialist, the TLD server. Now this server is the expert on all things .com, and it knows exactly who the official record keeper is for the site you want. It sends you to the final stop, the Authoritative server. That server holds the treasure, the final secret IP address.
And all of that, the whole three-step dance, it happens in milliseconds. It's just unbelievably fast. And now, with that IP address secured, the name translation part of our story is over. Your computer knows the exact digital street address it needs to visit, and the real physical journey of your request can finally begin.
Okay, so your computer gets its message ready. Something like, "Hello server, please give me the homepage." But it doesn't just send it out in one big chunk. The internet has a much cleverer way of sending data.
It breaks the message down into these tiny little digital envelopes called packets. Each packet contains a small piece of the request, plus the destination IP address and its own address for the return trip. This is absolutely key for sending info efficiently across a super busy network.
And this perfectly illustrates what happens on the other end. When all these packets arrive at the destination, they might be totally out of order. So the receiving computer's job is to collect all of them and then reassemble them in the correct sequence. The source material uses this fantastic analogy. It's like reassembling the perfect Lego set after it was shipped to you in a bunch of little pieces.
So what's the actual path these packets take? Well, it starts at your computer. From there, they're sent to your home router, which is kind of like the local post office. And that sends them to your internet service provider. From there, they hit the massive superhighways of the internet, hopping from one router to the next. Each router reads the destination IP and just points the packet in the right direction until, finally, it arrives at the server. But wait, hold on. The journey is not over. We've only sent the request. Now the server has to package up the entire website and send it all the way back to you, and it follows a very similar path, just in reverse.
So, the destination server gets your request, it gathers up all the files it needs, all the text, the images, the code, and it does the exact same thing your computer did. It breaks all of that website data down into thousands of return packets, addresses them to your IP address, and sends them flying back across the internet.
So, the time for that entire round trip, the DNS treasure hunt, sending the request packets, the server processing everything, and then sending all the website packets back to be perfectly reassembled by your browser, is often around 0.2 of a second. It is just mind-bogglingly fast.
So what this all really means is that behind every single click you make, there's this astonishingly complex ballet of communication. A global address book lookup, a journey across continents in tiny digital envelopes, and then a perfect reassembly on the other side. All of it happening in, quite literally, the blink of an eye.
And that really makes you wonder, doesn't it? This incredible invisible system is just one of many that power our modern world. What other complex journeys are happening all around us, completely hidden from view, every single day? It's definitely something to think about.
Now you know the why behind this concept. If you want to master the systems that run our world, hit subscribe for more foundational explanations.